Hi everyone. So in this video I'm going to do the solution to question 3 of the AP Calculus AB 2022 free response exam. Okay. So this is one of the questions that is not allowing use of a calculator. Okay, so you're presented with a graph, and this is a graph of the derivative of some function f. Let f be a differentiable function with f of 4 equal to 3. On the interval between 0 and 7, the graph of f prime, the derivative of f, consists of a semicircle and two line segments as shown in the figure above. Okay, so we have a semicircle between 0 and 4, and then a line segment between 4 and 6, and a line segment between 6 and 7. Okay. Part A. Find the values of the function f at 0 and the values of the function f at 5. Okay, so how do you find the value of the function from its derivative? Well, you use the fundamental theorem of calculus. So namely you say, right, you know that if I integrate f between any 2 points a and b, or if you integrate the derivative of f, between a and b, then this is just equal to f of b minus f of a. Okay, and we know what the derivative f prime is, and we also know the value of f at 4. That's the only point to which we know the value of f, so that's obviously what we need to use. So now let's use that to find the values of f at 0 and 5. Okay, so therefore, let's do 0 first, so that means we want the integral from 0 to 4 of f prime of x dx. So this should be equal to f of 4 minus f of 0. So f of 0 is the thing we want to find out. So let me work further down. So therefore, f of 0 is equal to f of 4, which is 3, minus the integral from 0 to 4 of f prime of x dx. Okay, and what's that? So now you have to remember that an integral defines an area. So the integral from 0 to 4 is this area here, and this is the area of a semicircle. So the area of a semicircle, area of a circle is pi r squared. So area of half that is a half times pi times r squared, and here r is 2. Times 2 squared. Okay, but because it's under the axis, this actually counts as negative area. So the area here is minus a half pi times 2 squared, which is 4. Okay. So this is 3 minus a half times pi times 4. Okay, and that's 2 pi, so this gives you 3 plus 2 pi. Okay, so that's the value of f at 0. And we can do the same trick to work out the value of f at 5. So the integral from 4 to 5 f prime of x dx from, again, the fundamental theorem of calculus is f of 5 minus f of 4. And here we want to know f of 5. So that should be equal to f of 4, which is 3, plus the integral from 4 to 5 of f prime of x dx. Okay, so what's that? So the integral from 4 to 5 of f prime of x dx is this one. Okay, so this is a triangle. The base of the triangle has length 1. The height of the triangle was 6 here, goes up to 2. And this is a straight line, so 5, this must also be 1. Okay, so it's the area of a triangle with base 1 and height 1. So that means this area here is just a half times 1 times 1, which is a half. Okay, so this is equal to 3 plus a half, which is 7 over 2. Okay. So that's the end of part A of this question. And now let's have a look at part B. Okay, part B. Find the x-coordinates of all points of inflection of the graph of f between 0 and 7 justify your answer. Okay, so what's a point of inflection? A point of inflection on the graph is where it goes from having a negative curvature like this to having a positive curvature here. Okay, so in areas of negative curvature, the gradient is decreasing, and in places where it has positive curvature, the gradient is increasing. Okay, so at a point of inflection, this is a point at which the gradient switches from being increasing to decreasing. Okay, so if we look at the graph here, where does f prime switch from decreasing to increasing? There are 2 points where that happens. One is at the bottom of the semicircle here, so when x is equal to 2, and the other one is at the top of the line segment here when x is equal to 6. Okay, so that's the answer. We need to justify our answer, so that means we should define what a point of inflection is. So this is a point where f prime changes from decreasing to increasing. Okay, and as I said, that only happens at 2 points, where x is equal to 2 or x is equal to 6. Okay, that's the end of part B. Part C, let g be a function defined by g of x is f of x minus x. On what intervals, if any, is g decreasing for x between 0 and 7? Show the analysis that leads to your answer. Okay, so g decreasing means that g has a negative gradient. Okay, so what is g prime? Well, we know that g of x is equal to f of x minus x. So therefore, if we just differentiate this, we get that g prime of x is equal to f prime of x minus 1. Okay, so the graph of g prime looks the same as the graph of f prime, but just shifted by minus 1. Okay, so if we look at this graph here, and then try to draw what the graph of g looks like, I'll do that down here. Okay, so I've cleared up my paper a bit and just written the graph of g prime here as a function of x, and the important points are 0, 4, 6, and 7. Like I say, it's just 1 less than the value of f prime. So f prime goes as a semicircle between 0 and 4, starting at 0 at the origin. So g prime will therefore also be a semicircle, but starting at minus 1. Here, like this. Like this. Okay. Then f prime goes as a straight line between 4 and 6, and the y value goes between 0 and 2. So therefore g prime will be the same straight line, but the y value will go between minus 1 and 1. Like this. And it crosses the origin at the point 5. We basically worked that out in part A of the question. Okay, and then it goes down again, and f prime goes to 7, 1. So therefore g prime will go down to 7, 0. Like this. Okay, so to answer the question, on what intervals is g decreasing? That is where g is negative, and that obviously happens between x between 0 and 5. So g is decreasing if and only if the gradient at g prime is less than 0, and this only happens if x is between 0 and 5. Okay, that's the end of part C. So the analysis is just what I've done here. And then finally part D, for the function g defined in part C, find the absolute minimum value of g on the interval between 0 and 7, just for your answer. Okay, so we've worked out that g is decreasing between 0 and 5, so its value of g is getting less and less. Then, because the gradient is positive between 5 and 7, g starts to increase again. So the minimum value must be at x equals 5, right? So I think I can write that here. So g is decreasing on 0 less than equal to x less than 5, okay, and it's increasing on x greater than 5 less than or equal to 7, or about less than 7 if we're being precise. So therefore g must be minimum at the point x equals 5. Okay, and it wants you to find the minimum value of the function. So in other words, what's the value of g at 5? Well, luckily we've worked out the value of f at 5 already. It was 7 over 2, and g is just that minus x. Okay, so g of 5 is equal to f of 5 minus 5. F of 5 is 7 over 2, so that's 7 over 2 minus 5, which is 10 over 2. So this gives you an answer of minus 3 over 2. So therefore the minimum value of g on this interval is minus 3 over 2. Okay, and that completes the answer to part D, and that completes this question.